So first thing we want to discuss is what we call the discriminant. The discriminant is going to be whatever is underneath the square root in your quadratic formula. So underneath your square root, you have b squared minus 4 times a times c. Remember when we have been working on the quadratic formula, I've been highlighting that on my screen. So your discriminant is going to be that highlighted portion that we always type in our calculator first. So whatever number that happens to be, that number itself is called the discriminant. That number is very unique because it tells us how many solutions we're going to have if we were to graph it. So in the instance that you take b squared minus 4ac, you plug in a, b, and c, and you get 0. So you take that highlighted portion, you plug it in your calculator, and it gives you 0. That tells us that you would have one real root. If you were to graph it, that just means that the vertex is the only point on your parabola that would touch the x-axis. The second scenario, if you would take b squared minus 4ac and you got a number greater than 0, that just means any positive number that you get, you're going to have two real roots. So real being you can graph them and see them on your x-axis. So for example, right here and right here for this example. So right there you have two roots because your graph is crossing your x-axis 2 times. The last scenario is when you have b squared minus 4ac and you get a negative number. So keep in mind, we just talked about negatives underneath our square root. If you get a negative number underneath your square root, there are two imaginary solutions or roots. So mark that no real roots out. We're going to write two imaginary. What that really means, if we were to graph a parabola, it's not ever going to cross your x-axis. Your solutions will be imaginary. You can't see them because your graph doesn't ever cross the x-axis. So anytime you get a discriminant and it's negative, you would have two imaginary solutions. So on your homework assignment today, you're going to have some problems where I say, find the value of the discriminant. So you're going to find b squared minus 4ac. And then you're going to have to tell me, based off of that number, how many and the type of roots that you are given. So if I got a discriminant with a value of 0, I would write one real root. If I got a value that was positive, I would write two real roots or two real solutions. If I got a value for my discriminant that was negative, I would say two imaginary. Let's practice. So here we're going to figure out what type of solutions we have. To do that, we have to find the discriminant. The discriminant equals b squared minus 4ac. So looking at the first question, number 1, we have 3x squared minus 11x plus 10 equals 0. We already have 0 on one side, so we can go ahead and say that, a is 3, b is negative 11, and c is 10. So to find my discriminant, I'm going to take negative 11 squared, b squared, minus 4 times a, which is 3, times c, which is 10. I want you to type that in your calculator exactly as it's written. Make sure you include those parentheses. What do you get when you type that in your calculator? 1. So the value of the discriminant is 1. Then you have to decide, is 1 0, positive, or negative? It's positive. So if I get a positive discriminant, I have 2 real solutions, or roots, or zeros. So technically the answer to my question isn't the 1, it's the 2 real solutions, because the question I was being asked was, what is the type, or what type of solutions do we have? We have 2 real solutions. We didn't find them, but we know if we did, we would have 2 and they would be real. Question number 2. We have 8x squared plus 2x plus 8 equals 0. It's already said equal to 0, so A is 8, B is 2, and C is also 8. To find my discriminant, I'm taking B squared minus 4 times A times C. So 2 squared minus 4 times 8 times 8. So type that in your calculator just as it's written on the screen. You should get a value of negative 252. So negative 252, you have to decide, is it 0, is it positive, or is it negative? Since it's negative, you're going to have 2 imaginary solutions. So since 252 was negative, we know we would have 2 imaginary solutions. So the whole first page of your assignment's going to be finding the value of the discriminant for the first 3. The next 3 questions on your assignment are going to be just like this. Find the value of the discriminant and then tell me what type of solutions you have. We just did an example with 2 real. We did an example with 2 imaginary. The only one we missed would be if I got 0, I would just have 1 real solution. So going back to our quadratic formula, now we're going to look at our quadratic formula and we're going to end up with a complex number, meaning we're going to have an imaginary at some point in our answer. So looking at 6x squared minus x plus 3 equals 0. It's already said equal to 0, so you can go ahead and tell me that A is 6, B is negative 1. Remember, there's that 1 sitting right there. And C is 3. Just like yesterday, we're going to go ahead, fill out our quadratic formula using those 3 numbers. So negative B plus or minus underneath my square root, I need B squared. Well, B is negative 1, so negative 1 squared minus 4 times A, which is 6, times C, which is 3. All divided by 2 times A is 6. So automatically getting 1 point for just writing this all down. And then just like normal, we're going to take what's underneath our square root and type that in our calculator. So in parentheses, negative 1 squared minus 4 times 6 times 3. That's our discriminant that we were just finding on the previous page. Somebody tell me what you get when you type that in your calculator. Negative 71, perfect. Is 71 a perfect square? No. Actually, if you look at 71, you cannot divide 71 by any perfect squares. So for our answer, there's only one thing we need to do here. We've got to get rid of this negative that's underneath our square root. Remember from earlier, if we want to get rid of a negative underneath our square root, we bring it out, and what do we make it? We make it I. So we're going to have 1 plus or minus I square root 71, all divided by 12. It does not reduce, so I'm going to leave it just like this for my final answer. So we did our quadratic formula just like we always did, except now we got a negative underneath our square root. Bring it out from underneath the square root and put an I right there in front. Questions on this one? All right. Let's practice one more. This time we do not have 0 on one side. Remember yesterday I told you I never want to make the x squared term negative. So I'm going to move 8 and move the 8x. So I'm going to add 8 and subtract 8x from both sides. So when I do that, I get 6x squared minus 8x plus 8. We always want to write in standard form. X squared should always come first, then your linear term with just the x, and then your constant to follow. So for this one, we're going to use an a value of 6, a b value of -8, and a c value of +8. So take a moment and see if you can fill out the quadratic formula using those 3 numbers. Hopefully you have 8 plus or minus the square root of -8 squared in parentheses minus 4 times 6 times 8, all divided by 2 times 6. So that's always our first step. Our second step, we're going to take and figure out what the discriminant is, the number underneath our square root. So when I take -8 in parentheses squared minus 4 times 6 times 8, I end up with -128. If I look, 128 is not a perfect square. So I'm going to have to break it up into 2 numbers that multiply to give me 128, but I want one of them to be a perfect square. So if I take, oops. If I take 128, I would break it up into the square root of 64 times the square root of 2. So 64 is the largest perfect square that I can divide 128 by to give me 8 square root 2. But don't forget that 128 was negative, so what do we also need to do? Put the I. So 8 plus or minus 8i, don't forget that I, square root 2, all divided by 12. The last thing you need to check for is to see if you can reduce. Remember, it's only these three numbers that get reduced. Can you reduce all three of those? Yep. Divide all three of those numbers by 4. That gives me 2 plus or minus 2i. The square root of 2 stays in there. Divided by 3. And that right there would be my final answer. So I took 8, 8, and 12, divided them all by 4 to get my reduced final answer.